Hello everybody, we're on day 2 and here's just a couple of hints for you. Part 1 and 2 has a video related to it, so you can go ahead and watch those videos and do those parts of the investigation. Number 3, so keeping in mind the rubber band experiment above, answer the following questions. So we're going to get into this question here, where a group of students in Iowa, they do the same bungee jump experiment, but they came up with this rule for the length of the rubber band in centimeters compared to the weight in grams that was added to that rubber band. Okay, so they came up with length is equal to 30 plus 0.5 times the weight in grams. So going to the next page, what you're going to do is make a table of values and a graph using that rule that they came up with. So in that rule, we'll make a graph using these points where it's the weight and the length of the rubber band. The values of W go from 0 to 120 in steps of 20 grams. So what that means is the weight of the weight that gets put onto the rubber band goes from 0 to 120. So you're going to fill in all of these on steps of 20. So 0, 20, 40, 60 on down to 120. And then we're going to use that formula that they came up with, the relationship between the weight and the length, and fill that in. So when the weight is 0, if I plug that value into my equation, I get 30 plus 0.5 times 0. Well, 0 times anything is just 0, so I'm left with 30, and that's the output. So what we have here is our independent variable, or our input, is over on this side, and then our dependent variable, the one that depends on the other one. So that's the way we write formulas or functions, is that the length depends on W, and this is our relationship. So the dependent variable is kind of our output. Okay, and so you could just go down the line and plug the value into our function and find out what we get. So 20 goes in there, 20 times 0.5. Well, multiplying by 0.5 is just like taking half of something. So 20 times a half would be 10, and then 10 plus 30 is 40, and you can fill out the rest of the chart there. Okay, then you're going to take that information and put it onto a graph. So again, we have our independent variable is usually our x value, so kind of our x-axis is our independent variable, which in this case is W. And I labeled these on 20 gram increments. So you can split up these increments any way you like, but you're going to probably run out of room if you go 1, 2, 3, right? 1, 2, 3. Your 20 would be way over here, and it wouldn't fit onto the graph. So that's why you have to split up the increments into bigger portions. So 0 to 20, 20 to 40, and so on. And then going with my dependent variable, so how does that change? Well, it goes from 30 to, I don't know what it goes to actually, so you'll have to figure that out. But I thought probably at 10 increments would be pretty good. So you notice that the scale on this axis doesn't actually match the scale on this axis. So even though it looks like it's going up 1 over 1, it's actually going up 10 over 20, right? You have to read the numbers to see what the actual slope of that line is. But I put in the two values that I came up with. 0 weight attached, I got a length of 30, and 20 weight attached, I got a length of 40. So that's just 2 points, but you're going to graph all the points and see how the graph looks. And then you can go ahead and answer these questions about how the graph changes as the weight changes. Okay, flipping over to the next side, another question for you to answer. And then we talk about this bungee business. So you're going to put together, using this market data, you're going to put together another graph here, graphing the relationship of the price per jump to the number of customers. So what they're trying to graph here is if I charge so much money, this is how many customers I'll have. So 0, if I say, oh, it's just free to jump, then maybe we get 50 people to try it. If I charge $5, then maybe we get 45 people to try it. If I charge $10, and so on. So you're going to go ahead and graph those, and it's important to label your axes and write your scales. So I'm not really sure. It goes up to a maximum of 50 customers, so you kind of don't want to go off the scale. So it might be that I thought probably increments of 5 would work for this, and in this direction we don't want to go over 30, so maybe increments of 5 would work there too as well. Go ahead and try that out and see what you get, and that's just a little hint for you. Then the next part, they actually give you the rule, and then from the rule you're gonna get your values again. So this is again just like the previous problem. You have a function that is that's independent variable is p, and its dependent variable is n. So as I put in different prices, I will get different outcomes, and you'll go ahead and fill in that chart and graph just like before. Okay, so that's it for hints. Go ahead and answer all these questions, and we'll see you on the next day.